You're going to see me twice on the screen, unfortunately, because that way you guys can see what I'm doing as well. Okay, what did I want to say? So, let me just switch the camera. I am going to help you guys with the thinking of the second question you guys are doing for the first page on the structural isomers of alkanes. The reason why I'm doing the second question is because the first question is really easy, and the second one is asking you to find 5 molecules. So, they have given you C6H14, and they want you to find the structural isomers of that molecule. I've gotten the molly-molds out because I think the molly-molds are really useful to help you visualize what's going on. So, a structural isomer are molecules that have the same number of carbon and hydrogen or the same molecular formula. They're just arranged differently in their bonding pattern. All right, do you want me to write that down? Are you okay? We're okay? Mm-hmm. Write it down. Okay. So, structural isomers are molecules with the same molecular formula but different bonding patterns. Okay? Whenever I'm tackling a question like this, the first thing I do is the straight chain because that's the easiest one, and then I can work my way through it to make sure I got everybody. So straight chain, we're doing 6 carbons. That would be 1, 2, 3, 4, 5, 6. And then fill in those hydrogens. We have CH3, CH2, 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 CH3. It also helps when you're doing your structural isomers to name it. This is hexane. The reason why I name it is to make sure that I don't accidentally do 2 of the same. All right? We okay? Okay, I'm going to switch to the other side of the camera. Are you guys still writing? I can still see you writing. All right, I'm just going to put together that organic molecule so we can start seeing what it looks like and we can start understanding what's going on. Hopefully all of my carbons here have 1, 2, 3, 2, 3, 4 bonds. All right, can I switch it over? Yeah? Okay. So I'm just showing you guys what I'm doing. It's like Inception. Do you guys want me to turn the screen off or do you guys want to have it on? Is it helpful to see it? It's good? Okay. So what I'm trying to do is I'm putting my 6 carbons together to make a carbon chain because I want to basically see what I'm doing. It's not going in. All right. There we go. So here's my 6 carbon chain. Like that. Like that. The other ones are zigzaggy. Why aren't you zigzaggy? It doesn't need to be zigzag. I'm just trying to understand why mine's being weird. All right, so that's my 6 carbon chain. The other thing I'm going to do is I'm going to add the hydrogens on there. And the reason why I'm doing it is just so you guys can see 3-dimensionally what we're talking about with the molecules. And just think about it visually. I figured this is a nice way to kind of play and think and learn. So N carbon, remember all carbons need to have 4 bonds to it. So this is an N carbon and has 3 hydrogens attached to it. That's why I write CH3. All right, this carbon here has 2 extra bonds because 2 of the other bonds are attached to the carbons. So that gives me 2 hydrogens there. And then so on and so forth. So this one's also 2. That's another 2. And then I have a 2 and a 3. Hopefully I've grabbed enough and I did my math correctly. That's not a workable carbon. I don't know what piece you are, but you are not part of my set. And then the last one has 3. Let me grab one more. So what I have here is hexane. Cool? All right, some of you guys almost made it. Now it rotates around like that because it can do that. But either way, it's still hexane. Now, when I do a structural isomer, I have the same molecule with the same number of carbons and hydrogens or whatever the molecular formula is, but there's different bonding patterns. So the first way that I solve this problem is I take the N carbon off and I'm trying to move it somewhere else on the chain to make a branch. So for example, if I had this guy over here, I can't put it back onto this first carbon or I can't put it back on the N carbon, because if I do that, then it's still hexane. So I go into the next carbon here, we're taking one of these hydrogens off, we're moving that guy onto the end, and we're putting that guy here, because now I have a methyl branch. So same formula, different bonding pattern. Let's go to the piece of paper so we can write that down. So all I've done is, what is it going on? Trying to get it to work with my hand because I'm right-handed. Okay, so all I've done is I've taken the end carbon and I shifted it somewhere else onto the chain. Not onto this carbon, not onto this carbon, because then it's still hexane. So I'm moving it onto this carbon here. So my longest chain is now 5. 1, 2, 3, 4, 5. I can move the methyl onto carbon 2. On either side, it's still the same molecule. So I've moved it over here. So now I have, naming wise, 2 methyl, and I have 5 now, so that's pentane. Pentane. All right? So that's where I move that guy on this molecule for my shape. The next thing I then try to do is I try to take that methyl and I move it down the chain to see, can I still get another molecule from here? All right, can I move the screen? Yes? So, I'm taking this methyl, popping it off, taking off one of the hydrogens, so that way I have a space for it. You see now the hydrogens moved onto here, and now I have the methyl in the center. So when I go to draw the molecule, I've taken this carbon over here, and I've moved it down one onto the center carbon. So I have still the pentane, 1, 2, 3, 4, 5, except the methyl is over here. So if I was to name that guy would be named, help me out, 3-methyl. So all 3 of these still have the same molecular formula, still have the same number of carbon and hydrogens. I've just moved things around and bonded them differently. Now we know from the question, they say there's 5 potential isomers. So next thing to think about, if I take the methyl off here, and then I take this guy off, put the hydrogen over there, put the methyl over here, do I have a new molecule? No, I don't, because if I flipped it around this way, it's still on carbon number 2. All right, so I have maximized the number of carbons I can get off this guy. Cool? All right, now I'm going to take this methyl off. I'm going to take another methyl off. And again, I'm now going to deal with a 4-carbon chain, and I got to think about, okay, how do I bond my methyls to this 4-carbon chain so I can get a new molecule? So I want to move this hydrogen off. like that, so that way I have three hydrogens and three hydrogens on the end. No point in me putting any of these branches on the end, because if I do that, then it's now the longest chain. So I want to keep these two guys as branches. So let's say, for example, I put both of the branches on this carbon here, number 2. Bop up, bop up. Looks like that. Let me write it down, because I'm mindful you guys can't always see what I'm talking about here. Okay, so what I've done now is I've taken another methyl, this guy over here, and I'm moving it down the chain. Now I can move it onto this carbon, sorry, I can't move it onto this carbon, because that's an end carbon, and I can't move it on this carbon, that's an end carbon. So I'm going to move it onto this second carbon here. So now we have 1, 2, 3, 4. I have this methyl, and now I have this methyl on over there too. And then I fill in my hydrogens. So that's CH3, CH2. That has no hydrogens on there. If I look at that molecule that I've made with these two branches. So this carbon here attached to a methyl, attached to a methyl, attached to a methyl, attached to a carbon. There's no hydrogens on this guy directly. All right, and then this guy's CH3. So again, always name your molecule because it helps you make sure you don't make the same thing twice. So this is 2,2-dimethyl, in this case 4 butane. Cool. Now we know there's 5, so currently there's 1 more molecule. So what I'm going to do is I'm going to take one of these methyls off and move it. So pulling this methyl off, pulling one of the hydrogens off, putting the hydrogen where that methyl was, putting the methyl now onto this guy here. Now the molecule is really, really different from what we started with. So now I have 2,3-dimethyl propane. Or sorry, butane. Running out of space. I'm going to have to draw this guy over here. So 1, 2, 3, 4. Doesn't matter if you guys draw these guys on the same side or on opposite sides. Doesn't, because they can rotate these bonds. So 2,3-dimethyl butane. Those are the 5. All right. No point in me detaching this methyl and moving it down because then I still get 2,2-dimethyl. All right. And if I take another carbon off, let me show you what I mean. If I take one of the methyls off from the end chain, so this is the end chain, take one of the methyls off, everywhere that I can put it is at the end. There's nothing, actually, if I do this. No, if I do this, then we're back to 2,2. So nothing else I can do, so I've gotten all my isomers. So that's what we're thinking about when you think about isomers. You're basically just taking the molecule and you're breaking it apart and rearranging it. You still have the same number of atoms that you're dealing with and the same type of atom numbers. It's just bonded in different ways. So those are structural isomers. Does that help? Cool. All right, so keep working on those SciPad pages. It might take you one more day actually to do this now that I think of it, but hopefully you guys got it now. That's why I gave you guys the models, because I figured that would help.